Hi, I'm Kevin, and I'm going to be talking about thought experiments in computer science. So, you guys are probably all really familiar with the same introduction, so I'm not going to worry too much about it. I'll just assume that you guys know what's going on, so you can save maybe like 30 seconds here of all of our lives. So, thought experiments. Just like the thought experiment that you can imagine that you just saw, they present kind of the space of imagination that we have. And not only do they occur in places like the previous one in ethics, we also see them in physics with the twin paradox dealing with special relativity, Descartes' melting candle dealing with the nature of persistence of existence. So what we see here is a contrast between what is conceptually possible and what's actually possible. By dealing with these, we can expand our minds into this much wider space and think about what we previously understand in new and different ways. So I guess how this kind of ties into computer science is that there are two aspects to how computer science interacts with thought experiments. The people of computer science are very similar, I feel, more to physics people. They're very analytical. They focus on logical reasoning and use this to analyze certain situations. The questions they deal with, however, are more philosophical, particularly since I'll be analyzing artificial intelligence or AI. These questions deal with the nature of intelligence and how we might be able to model that in computers. So while both of these fields, physics and philosophy, have a long history of using thought experiments to further their research, computer science has not been able to implement this similar ability and has actually found it to be something of a roadblock. So my main argument in this presentation will be the reason for this is a rhetorical disconnect between the two audiences here, between the philosophical issues and the physics-like people that prevents productive gain in the field. So here's a brief outline of a couple things that I'll be talking about if you want to glance at so you know what direction I'm going with this. Okay, so physics has a long history because physics is the way that we interact with the world. When we move our hand close to a flame or when we push a table, that's physics happening. So people have always been interested in these phenomena. And because of this, we all have an intuitive way about how the world works. A good example of this is this video, which I think should fit within your conception of how the world behaves. Unless, of course, we get selected. It's a lot faster on my computer, just throwing it out there. And it's really slow, so I'm not going to worry about it. But maybe we'll come back to it later. But in the video, oh, there we go. That is giving me endless laughs. Anyways, so yes, we all have different ways about how the world works. And so we see these things on a regular basis, and I have no problem with it. What really causes physics to continue as a field, however, is the things that we can't explain. It's things like special relativity, like astronomical phenomena, or quantum physics, that really cause puzzles here. And so thought experiments allow us to get at this. Galileo, for example, famously had his own thought experiment about dropping items off of the Leaning Tower of Pisa that enabled us to understand that, well, all things fall at the same rate. So contrast this a little bit to philosophy. In philosophy, we face much more different problems, considering what is, simply maybe what is. And so when we get into these sort of conversations, we're dealing with much more abstract issues that cannot be empirically determined by eventually, at some point, dropping items off the tower. But regardless of this, we all do have a sense about how the world works from a philosophical perspective as well. For example, I myself can claim that I am conscious, and I know that I'm conscious. However, I have no proof that a dog would be conscious, or that any other being, or any of you here, all of you might be zombies. And so, we really can't come to a well-determined answer to this issue. So how do these two tie together into a disconnect? We can consider it from a rhetorical perspective. Lacaille's quote, I quote as saying, "Thought experiments function to change our views, to force or persuade us to agree and to help us ignore the underlying assumptions involved." Persuade. That seems like kind of a key word to indicate a rhetorical perspective here. So let's look at Lloyd Bitzer's qualifications for a rhetorical situation. I'll be focusing mainly on the first two. So let's limit the thought experiment description to just philosophical thought experiments. Exigence. Why do we need this? Good question. People have been debating these questions for a very long time, and yet at the same time, there isn't a strong sense that we need this to happen. We ask ourselves, why are we here? And having not been able to find an answer for so long, there's not a sense of direction with that. The audience for philosophical thought experiments are other philosophers who talk to other philosophers about this. And so there's a very close community that's unable to actually enact any sort of change based on much of what they discuss. Contrast this to physics. To physics, as I mentioned before, there's always a strive to explore the world around us to better our standard of living. Whether that's through slinkies or Large Hadron Colliders, there is a very clear impact on and direction for this. And the audience, everyone is paying attention. Everyone wants to know so that they can find these sort of innovations. So, tying this back, now that we have an established ground in physics and philosophy, let's get into computer science.